Okay, this is section 9.5, Nonlinear Systems of Equations and Inequalities. And we're going to start off by looking at the number of possible solutions for a nonlinear system, and then looking at a graphing way of finding those solutions. So a nonlinear system of equations has at least one nonlinear equation. So just to kind of refresh your memory on the types of equations that you might see, I have some listed down here. Polynomials of degree 1 and degree 2, so degree 1 is linear, obviously that's a line. Quadratic is a parabola. Then we have our conic equations, circles, ellipses, hyperbolas, parabolas, and then we could also have logarithmic or exponential functions that are also possible in a nonlinear system. So back up here at the top, when solving a nonlinear system, sometimes it's helpful to identify the type of type of equation you are given and the shapes of the graphs. And then visualize those graphs to figure out the number of possible intersection points, which would be your solutions. So if we take a look down here, I have this one worked out, but we'll go through it. It says, draw sketches showing the different ways each pair of relations can intersect and identify the number of possible intersections, which are the solutions. So the two shapes that I have are relations, are a parabola and an ellipse. So I just drew a bunch of ellipses, and then parabolas were easier to draw over. So if I have a combination of a parabola and an ellipse, so here's my ellipse, I could draw an upward-facing parabola, and those two would not intersect. I'd have no solution. I could also draw a downward-facing parabola, so there's an example there that doesn't intersect. Here's another one that's off to the side. It doesn't intersect. We could also draw parabolas to the right, or facing right and facing left, that would also not intersect, so that would be no solution. In our next pairing, just a couple examples. Here's our ellipse, and then our parabola just touches at one point. So it can touch on the side, it can touch at a vertex, so that would be an example of one solution. Next pairing, here's our ellipse. This time our parabola intersects twice. We could also look like this and intersect twice, so that would be two solutions. The next one, just a couple examples of where it could intersect and have three solutions. And then our last one, again, the intersection of the ellipse and the parabola creates four solutions. Okay, so those are just an example of a couple of the sketches that would give us those many solutions. There's not a way to give us 5 solutions, so we've kind of exhausted our list there. So now let's look at solving a system by a graphing method. So it says identify each equation in the system. Is it a line, parabola, circle, ellipse, or hyperbola? And then solve the system by graphing. So here is our system. Our first equation, x squared plus y is equal to 4. Well, that's going to create a parabola. Our second equation, x plus y is equal to 2. That's a line. So we have a system of a parabola and a line. So with graphing, if we take a look over here, our first equation, if we solve this for y, we get a parabola that's going to be facing down because a is negative. We can find the vertex, x is equal to negative b over 2a. So x is equal to 0. Substitute that 0 back into the equation, and we get the y coordinate of the vertex to be 4. So we can plot that point over here on our graph. And then it's easy to find the x-intercept, set your equation equal to 0. Solve, so we end up with two answers, plus or minus 2. And then we plug those back in again to the equation to find the y-coordinates, and they end up both being 0. So then we get our y-intercepts here and here. And we can sketch in our parabola, and that's on the blue line that I have. Then for the linear equation, again, we can solve that for y. Our y-intercept is 2, so plot that. Our slope is negative 1 over 1, go down 1 over 1, connect those together, there's our line. So we're looking for our intersection points, which happen to be, in this case, negative 1, 3, and 2, 0. And you need to note that our graphs are going to give us an estimated solution. This one's, neatly done by the computer, and we can see exactly where they intersect, but what if these weren't whole numbers? What if they were decimals? What if our sketching of the graph by hand wasn't so accurate? We're just going to get some estimated solutions. So in the next video, we're going to look at another way of solving these to be more precise using algebra.